In this video, we're going to take a look at electron configuration. So this it goes off of the previous video for the electron filling diagrams or orbital filling diagrams. So here we have 2, 4, 6, 7, 8. We have 8 electrons. So 8 electrons describes oxygen. So this is the orbital filling diagram or electron filling diagram for the element of oxygen. So electron configuration kind of makes your work a little bit easier. So because in electron configuration, instead of actually drawing in where the electrons are, all that you do is you put a number on the letter which represents the atomic orbital, and then that will tell you how many electrons are in there. So for example, instead of writing this out, because this is the orbital filling diagram for oxygen, if I just wanted to write the electron configuration, that would be 1s. Well, how many electrons do I have in the s? Well, I've got one here and one here, so 2. So I would just put a 2 as a superscript. Like, it looks like s squared, but it's just 2. So I would say 1s2, and here I would say 2s, and once again I've got 2 electrons here, so it would be 2s2. And in the P, I've got 1, 2, 3, 4. So I've got 4, so it would be 2P to the 4. So the electron configuration for oxygen would just be 1s2, 2s2, 2p4. So you see how it's the same information. It's no different information. It's just instead of writing the actual electrons out, you're just putting the numbers in. So let's say, for example, if I wanted to do the electron configuration for, let's say, aluminum. So aluminum has 13 electrons. So we need to draw these 13 electrons. So according to the off-ball principle, I would know that 1s comes first, and I would fill that up, so it's a 1s2. And then the next I would have is a 2s2. And then after that comes 2p, but this time I've got a full p, a full 2p, so it would be 2p6. So then I keep getting bigger, so I would have a 3s2, and then I would have a 3p1. So if we add these up, 2 plus 2 is 4, 4 plus 6 is 10, 10 plus 2 is 12, and 12 plus 1 is 13, which gives me my total number of electrons for aluminum. So this is the electron configuration. Now notice it would be the same information as if we drew out the orbital filling diagram, but instead of drawing the electrons, we just actually write in the numbers.